Welcome to Link G4x Training Part 58. In this training tutorial, we're going to be focusing on our power management software feature that's been newly added. This is going to allow us to have traction control in a different manner that we already cover in a previous training module in our training course. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our power management feature in our Link G4x software. Our power management is going to take the place of traction control for most applications. It's something that's newly added to the software, so I wanted to have a dedicated tutorial showing how to utilize this new feature. I've used it actually on a couple different applications now and it works great, so this is going to be my go-to instead of using the traditional traction control that we've covered in the training course earlier. So I don't know what video specific tutorial that was, but we have a video on traction control. So this is going to be essentially the new way to implement traction control. And I find that it works extremely well and it's very easy to set up. Let's take a look at some things here in the software and then we'll talk about our power management and how to utilize it. Now I am using the engine simulator here for this tutorial just to demonstrate a few things. We will be taking a look at two different calibration files, two different examples of utilizing the power management in a completely different way. We'll also take a look at a data log here as well tied to the one calibration file so you can see what the power management feature is going to look like when it's actually kicking in and starting to be used. So let's go in here. I'm at the top of the software here under Basics tab. We go here into Layout. We can go down and pick our layouts. We can also navigate across here. I'm going to go right into the Traction Control tab. Now in here, I want to talk about traction control real quick. The way the traction control is going to function, it takes a look at our driven and undriven wheel speeds. It figures out a percentage of difference between our driven and undriven speeds. So if we're starting to lose traction, our percentage of slip, as it's known, is going to go up. That makes sense. So what we do here in the traction control is that we specify, depending on how this table is configured, a percentage of slip that we don't want to exceed. It can be a two-dimensional or three-dimensional table. If we exceed that percentage of slip, it'll kick in to starting to reduce the power down. So it can utilize that in a couple different ways. It's tied to the torque management in order to make it work. We'll find here that we have a couple different ways we can start to implement this. We can start to try to close the throttle, pull spark timing, reduce the boost. We can have a percentage of ignition cut. What I find here with the traction control is that there's not enough fine adjustment to really make it work the way I'd like, which is where the power management feature comes into play. We can implement the power management feature in a couple different ways and essentially replace our traction control feature here. So let's take a look at our power management. Now this layout that I'm using here probably looks familiar if you've watched a lot of the other tutorials, but I've added some new layouts in here towards the end. Specifically go down to rows here. We have power management at the end here. So probably want to go ahead and download this new layout that I've added to the training course folder. If you've already downloaded the training course folder, re-download it again. This will be added in there, so you can take a look at this and use this in your laptop when you're going through the power management function. So taking a look here at our power management tab, we'll have over on the left here power management. We want to turn it on and configure some details. There's a race timer that the power management can be tied to, and that's its primary. The way it was designed, its primary functionality was actually to be working off a race timer. Now the way that Link has intended this to be used is going to be on a rear-wheel drive drag car that's looking at something like our drive shaft speed and it's looking at a launch time. Now typically drag race rear-wheel drive vehicles are going to use a trans brake on automatic. When you let go of the trans brake, the car is going to launch and that would start the timer. We'll take a look at how that's going to work and how we can configure everything in another example file here. I'm going to be on the simulator just showing you, just running through some basic setup and configuration in order to just demonstrate this, just some of the functionality here, just to take a look at it. And then we'll look again at a log and look at these other calibration file examples. But we'll find that the primary intended use here is to tie it to a race timer, although we do not need to do that, as I'll show in another example. So we also see here we have a couple different tables: speed error cut table, speed error ignition trim table. We have a speed target table, open loop cut, and open loop ignition trim. And these are what I like to use on street vehicles that aren't going to be tied into a timer. We'll look at that here. So looking at our mode here, let's turn it on. So we're going to go here and go from off to on. And we're just going to say yes here. It's going to put some default values into our tables. And we are going to unlock these windows here so we can bring our tables in. And we'll talk about what these tables represent here in just a minute. But let's go ahead and just pop them in there. Now let's go down our list of different things we can configure here. So the speed source. The speed source right now is set to driving speed. We have a bunch of different options here. We have general purpose speed, we have general purpose RPM, we also have driving speed, driven speed, so depending on where your speed source set, or individual wheel speeds. What this is going to do is point towards our speed target table. Notice this table here is a time-based You're using a race timer starting here at 0 seconds, which will be launch time on a drag vehicle, and counting upwards. It goes up to 15 seconds, although we can reconfigure this to have a longer race timer if you need, but if it's a drag race vehicle, 15 seconds is typically plenty long enough. So if I change it here to something like general purpose RPM 1, notice that the table here is going to be based on RPM now and not mile per hour. This speed target table is essentially going to be what we utilize setting up our cut. It can be ignition or fuel cut, or setting up our ignition retard. This is going to be a trim table, either adding or subtracting timing. Typically we want to take timing away if we lose traction. It's going to use this as a marker point. So when we launch, in this case of RPM, that would be drive shaft speed, we would have a certain amount of time into the run, and we put a certain drive shaft speed that we're going to allow the vehicle to have. If it exceeds that, then it can start to utilize our trip tables here. So we're going to have our speed cut and our speed ignition trim to start to try to...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.